So hello friends, right now I'm in a radiation lab and I'm surprised to know that Adamas University is the first private university to have this facility, radiation lab, in the northeastern area, and the other university is the Jadavpur University, which is actually a great achievement. So hello dear ma'am, can you give your introduction to the audience?
Hello everyone, this is Dr. Purva Bhattacharya from Department of Physics, Adamas University, and yes, you are absolutely right. This is actually the second university in the eastern zone, actually I can say the northeastern zone, which has this particular facility, the radiation lab, particular for students actually. And also this is the first private university where we are offering one particular program called post-MSc Diploma in Medical Physics. Other than this Adamas University, in the northeastern zone, only Jadavpur University has this course. So obviously this is a milestone and a feather, I would rather say, in the Adamas University.
Can you explain me about what kind of work takes place inside this lab?
Okay, so first let me tell you about these things that this is a radiation lab, but don't get scared about this radiation because you are all safe here. The radioactive sources are here, but they are safely located inside a lead shielding box, and we got the approval to open this particular program only after the approval from Atomic Energy Regulatory Board from India and after the BRC visit. So the main thing is to teach the students after the MSc, I mean in the course post MSc diploma, so about the radiation, how to handle that radiation, how to monitor that radiation, and how to get an idea what type of dose you are actually absorbing in our body. So here you can see there are mainly two setup. One is this is the TLD reader, which is helpful to measure the radiation that we are getting inside our body, and here we have another setup called the GM counter, the Geiger-Müller counter, which can be measured by using different sort what type of radioactivity is here. Okay. Besides that, we have also another setup going on here, but this is absolutely non-harmful. This is measuring the cosmic muon, which is coming continuously from the background. So in this particular lab, the students will be taught about this different type of radiation, how to handle them, how to use these two particular setup and also this setup, and they will be trained so that after doing this course, which is 2 years course, they will be called the medical physicists. They have to pass the BRC exam and also have to pass the RSO exam, and they will be a certified RSO and the medical physicist in any government or private sector.
Okay. Certification is provided, right, in the field of radiation separately?
Yes. The certificate they will after, this is a 1 year course. 1 year course means here they will learn here in 6 months for first semester, and we have a MOU with the NCRI hospital and also with the NRS hospital. So they will also be taught in that two hospitals. So after 1 year they will be sent to the internship to that particular hospital so that they can get the proper training how to treat the cancer patient, because the cancer patient needs the radiotherapy,
yes,
right? So after finishing these 2 years, they will be provided the certificate.
Okay. Other from hospital related jobs, are there separate jobs
Yes, for example, yes. For example, in the university or in the institute where there are some radioactive source, or maybe where they have some X-ray gun, or maybe some other radiation source. So they need one radiation safety officer who will know about everything about the radiation, how to handle them, how to protect the others. So they will be qualified for this post also, and the pay package is quite high. It is more or less starting from the 70 to 80,000 per month actually.
Great.
Yes.
And out of context, I will ask few things.
Yes.
Like basically our human bodies also consume some radiation, right?
Yes.
Even inside the food also we have some.
Yes.
I think the unit measuring for radiation is sieverts something.
Millisievert or sievert.
Okay, so like how many millisieverts or sieverts do we
There
consume?
there are some specific limit. For example, the person, for example, they are working in the hospital where they are continuously working with the radiation source. The AARP has prescribed a limit 20 millisievert per year, and for the normal public like you or no, he is also a worker actually. So, for you the specific limit is 1 millisievert, but usually in a normal case where we are not using the radioactive source, the dose that we absorbed is much lower than 1 millisievert.
Okay.
So, do not worry.
Okay, and since lead,
Lead,
right?
yes.
So that is one element or material that is used to like preserve the
Yes,
radiation.
actually I can show you now where is the sources.
Okay.
Don't worry. There is the lead box.
Okay.
Okay, in the corner
the
there is
locker?
the lead. Yes,
Okay.
it is locked and the number is known only by 2 of us.
Okay.
Nobody else.
Okay.
And that is the lead block, and the radioactive source are kept inside that lead box.
Okay.
So that the source basically emits some particle or some radiation.
The radioactive element is solid, right? It is
Solid. Now here we have the sealed source, so here it is solid. But you can have also the liquid source, but we don't have the liquid source.
Okay.
We have the solid source here, sealed source.
So even refrigerator also have lead, right? Can it prevent radiation from passing through it? Suppose, for example, if you are inside the fridge and there was an exposure of radiation, so can it protect us?
Yes, because in that case, but if you are there for a very long time, obviously there will be not from the harm from the radiation, other harm will be there, because some other radiation is also there, which is not protected by the lead. Okay. So that is a different story. But the main radiation which usually we scared of, the gamma radiation or the alpha beta radiation, they can be protected using a proper lead thickness, which is an element and which is this lead.
Okay. Okay, and thank you for your insights. It was quite helpful, and
Thank you.
I got to know a lot of things, and I hope the audience also got to know a lot of things as well. And
Thank you for your time.
Thank you for your time and consideration. It was a really great session, and have a great day, man.
Thank you. Thank you.